So to give a kind of a brief introduction, I hope you guys have heard about Sustainable Development Goals. It's kind of the priority for the entire world and the society to achieve a set of goals which cover both economic, environmental, and social aspects by the year 2030. So the main challenge which we have at the moment is how we're going to achieve the Sustainable Development Goals, because the context of different countries and different regions, even different people, is totally different. So we want to address and kind of address this issue to achieve all the SDGs by 2030 in a kind of a constructive and collaborative way. So giving that kind of a brief, I'll just go to my overview of presentation, what I want to cover today. I don't want to go into more details, but I just touch upon few research areas which I think will be very useful for you guys to get a kind of broad perspective on what we globally do in terms of sustainable development and sustainable development goals. So the first one, I'll touch upon what the sustainable development goals are, and then the new concept called planetary boundaries. Then we will be talking about how to implement the SDGs or sustainable development goals within those planetary boundaries. And finally, I'll be kind of briefing the challenges and opportunities that exist in achieving those sustainable development goals. So I presume that most of you guys have seen this diagram. So the Sustainable Development Goals are a set of 17 comprehensive goals, 169 targets, and 232 indicators. So when you see this as an overview concept, it looks very promising because it addresses a large number of aspects in terms of sustainable development. So for example, if you take the Sustainable Development Goals and classify, they cover the triple bottom line sustainability aspects like environment, social, and economic systems. And sometimes if you dig further into the details, you can see that is something beyond triple bottom line. So there are other aspects like dignity and justice, and how we're going to build partnerships between countries, regions, and within nations. So sustainable development goals, even though many of them kind of consider that as a concept which focus on the triple bottom line dimensions of sustainability, what we see is as a concept which goes beyond triple bottom line. And the problem with the sustainable development goals is that there are too many goals, as I said, and too many targets, 162 targets, 232 indicators. And the major issue is they are kind of interlinked and overlapping and therefore so complex. For example, if you have a particular problem which is related to another problem, so when you start addressing one particular problem, it becomes more complex than what we expect. So that's a major issue and the major limitation which we see in terms of sustainable development goals. And that's what we think as that will be a hurdle for achieving these goals by 2030. To put in a summary, like implementing and monitoring the SDG indicators is not straightforward, as I said, because it's quite complex, and economies are more complex than SDGs because different countries have different priorities. For example, if you take New Zealand, our priorities are quite different from the priorities which we have in Sri Lanka, and this might be totally different from countries in sub-Saharan Africa or kind of countries in the Southeastern Asia, because their economic systems are designed in a way that they will be addressing their own necessities and wants, so that the economies become more complex. So that means that we don't have so there's no one fit solution for all the countries. So even though SDGs are kind of a global concept, you can't achieve or you can't implement it in a way where you can implement to all other countries. This means that we need to kind of a multi-scale interdisciplinary frameworks, how we're going to tackle these different types of problems at different economic scales, which becomes more challenging for both nations as well as like policymakers. For example, the ministries like us, how we're going to implement the SDGs for countries like developed countries as well as developing countries. So then I'm coming to this new concept which we're gonna talk at the planetary boundaries. But before going into planetary boundaries, I would just want to give a small example so that you guys can relate to the concept in a more brief manner. So limits, when you see the limits, the term limits, for me, usually the first thing comes in my mind is this speed limit. So that's what the most relevant to us, for example, because we drive a lot. So for example, if you take this question, which speed is safer? So I have three options like 65 kilometer per hour, 80 kilometer per hour, and 100 kilometer per hour. So if you take the context of Sri Lanka, where on a normal road, you can drive up to 70 kilometer per hour. So 65 kilometer is the answer, of course. Okay, I don't think you can answer. Yeah, so 70 kilometer per hour is the speed limit. So that means in New Sri Lankan context, the speed 65 is the safer. But when you come a bit out of Sri Lanka, for example, if you take Australia or New Zealand, where I live, the speed limit is around 110K. So which means in this case now, all three cases become safer. So this means that a driver who drives in New Zealand, when he comes to Sri Lanka and start driving at a speed of 100K, it will be considered as not safe. And the one who thinks 80K in Sri Lanka is not safe, when he comes to New Zealand, Australia, he is pretty safe. So this kind of a context, we have similar limits for our Earth system. So where we live, the Earth. So Earth has the limits which we call planetary boundaries. So the entire Earth is balanced in terms of 9 key Earth system processes. For example, climate change, land use, water use, and the chemicals which we use in manufacturing, and the amount of forest that is which covers, and the land system change. For example, as a production engineer, you may have to construct your plant in appropriate location where you have to do some deforestation. So in those areas, you may have to consider what these environmental boundaries are. So for example, if you take these planetary boundaries, as I said, the 9 boundaries, these thresholds which have been defined at a global level. So for example, if you exceed one of these boundaries, so this red color circle shows the maximum limit of the Earth. So if you pass this carrying capacity, then we will be ending up in a huge risk, which we don't know how the future will look like. And then this green color circle, which I have shown, is a threshold, which we say that there's the safe, if you stay within this safe zone, then of course you don't have to face kind of devastating challenges which we currently face globally. So at the moment, as you see, climate change is in the yellow color zone, and biosphere integrity, that is how you're going to destroy the animals or other species in the forest lands. Also, the biogeochemical flows, the amount of nitrogen and phosphorus which you use in the production activities. For example, as a production engineer, you would have had experience working in FMCGs where you produce food, a lot of phosphorus and nitrogen go into the raw materials. Example, dairy products. If you have an experience working with Nestle or Fonterra, you can see those large amount of dairy products which consume huge lot of phosphorus and nitrogen. So these global boundaries, the problem is these boundaries are only at a global level, but environmental impacts occur both global as well as at local levels. So the problem is, again, economies are multi-scale, so you can't address an environmental problem with a boundary which has been set at a global level. So you need a boundary which will tell, or which will be useful to compare your environmental impacts at that particular economic level. So again, as I said, like SDGs, we need a multi-scale interdisciplinary framework to address this issue. The opportunity which we found through research is life cycle assessment. I'm pretty sure you guys have come across this approach, because when we were undergrads, Dr. Asela was used to teach us a lot. That is where I started moving into this field, where actually is a very well-known methodology to evaluate the environmental impacts of a product or a service throughout its life cycle. It evaluates all the inputs and outputs and finally converts all the inputs and outputs into a range of environmental impact categories. And the recent developments with this approach has gone beyond environmental impacts to address social aspects as well as economic benefits of systems. This approach is now kind of now 50 years old, and it's well built and well used within the sustainable development field. So what we came across with the solution, considering LCA as an opportunity, we developed an approach called absolute sustainability assessment. This framework is pretty simple, but what we did, we connected two different camps of sustainability assessment methods. So we developed this approach and just tested for different case studies, which I will be talking later in this presentation. So the two camps were environmental indicators, for example, the indicators which we use in life cycle assessment, and the set of thresholds which we can use as a boundary or the limit to compare your environmental impact in order to know whether your production or whether your organization is passing any limits in terms of environmental systems. So it's like combining the two camps of sustainability assessment methods to build upon a new framework, which we name as absolute sustainability assessment. So I just give a kind of a brief idea of the concept so that you can get a better idea of how it works. So what we did, for example, boundary, then we further downscale to a sectoral boundary and up to a product boundary. So for example, if you are a product developer or product designer in a firm where you're going to design some, let's say a kilogram of cheese, you can calculate what should be the maximum amount of environmental impact you can create during the production phase. And even this can be used for your entire factory or the entire dairy sector. At the same time, from the other school or other camp of sustainability assessment, where we can use indicators. As you may, I believe that you may have learned a little bit at least about life cycle assessment. So even though life cycle assessment is a well-established approach, it doesn't evaluate all the environmental impacts. So some environmental impacts are not addressed by life cycle assessment. For example, if you take soil quality loss, you can't evaluate using life cycle assessment. So what we did, we took the other indicators which are there in the SDGs as well as in planetary boundaries, and we studied how these different types of indicators evaluate different types of environmental impacts, so that when you combinedly use these kind of indicators, you have a wide range of indicators to evaluate a large number of environmental impact categories. So again, like we link those indicators with the boundaries so that you can evaluate the impact using those indicators and compare to the proposed environmental boundaries. So first of all, as I said, there are three different types of approaches which I was talking about: SDGs, planetary boundaries, and life cycle assessment. So we wanted to know what kind of linkage which is built between these three frameworks, whether there is some kind of overlapping so that we don't end up doing the same thing which each approach is doing. So what we did a kind of analysis in the last, I think a couple of years before. So we took all the indicators in the life cycle assessment, planetary boundaries, as well as the sustainable development goals, and we kind of mapped all those indicators into a driver pressure state impact response framework. So it's called DPSAR framework. So I'll just give a brief idea about what DPSAR framework through an example. Let's say as a government, since I'm a part of a government, I always want to give an example to my experience working with the government. So if you want to, let's say a company, Toyota, wants to increase their sales of cars, what they can do is, first, they can market very well about their cars. So they can keep these promotions everywhere and can give interest-free loans, etc., etc. So the people tend to buy more cars. That's one option. Other option is you make the public transport system a shit so that you have no other option than buying your car. So that's the other option. So in those cases, what government do is government don't invest on public transport or any infrastructure that is required to improve the public transport. So people get frustrated so that they will be buying their own cars. So here, the final outcome impact is people buying the car, and the driver is the poor public transport sector. So each activity in the society is linked to another activity in a way. So likewise, environmental impacts, for example, if you take climate change is not only about greenhouse gas emissions. It has impacts with, for example, if you deforest, you do deforestation, you not only destroy the trees, you make the soils poor. So soils poor means then there will be more soil erosion, which will lead to flooding. So flooding means then more sea level rise will happen. So this means a consequence, there is a kind of a chain of environmental impacts which are linked. So that's what we have tried to kind of map on this DPSAR framework. So when we mapped all these indicators, we found that, so for example, if you take the star one, the climate change, likewise, there were around 12 stars which we found that all these three frameworks combinedly evaluate those environmental impacts. So what we did here is, rather than applying all three separately, we thought we'll first study the linkages between the three frameworks and then use that linkage as a kind of way forward to evaluate a large environmental impacts without doing the operation again and again. So now I'll explain how this kind of a sustainable development project can be used in order to develop policies and make better decisions in sustainable development context. So I'm taking three of the case studies which I consulted or work with different organizations in New Zealand as well as globally, but I would like to give more context of the New Zealand projects because it's more relevant for you guys to relate to, because a lot of New Zealand food products, especially Fonterra anchor products, are exported to Sri Lanka. So there is a kind of a two-way communication between those two countries. So if you take the agri-food sector of New Zealand, so what we did, we first evaluate the climate impact of the New Zealand agri-food sector and horticulture industries and products. I know a lot of people love to eat New Zealand apples, so this is the case study of New Zealand apples as well. So what we did, we used a process-based LCA. So we manually calculated all the environmental impacts of the horticulture industries. So here we focused on apple, kiwi fruit, and wine, and evaluate the climate impacts of all those three products at a product level, industry level, as well as at a sector level. Then I don't know how many of you are familiar of this 2 degrees Celsius Paris climate target. So in 2015, global leaders kind of agreed upon limiting their global warming to well below 2 degrees Celsius. So that's what they call 2 degrees Celsius Paris climate target. So this climate target is related to a global carbon budget, so which suggests that this is the maximum amount of greenhouse gas emissions you can emit each year or by this particular year. So what we try to do, we use the 2 degrees Celsius global carbon budget as the limit, and then we evaluate the climate impact of each of these products and compare against those limits. So for example, if I show the result, so first of all, I'll explain how we first calculate such an approach. I don't know whether this is too much of information, but I think it might be interesting for you to know how these kind of policies which we make at an international level. So if you take a global carbon budget, for example, related to 2 degrees Celsius, we assign a share of the global carbon budget to the global agri-food sector. That means the global carbon budget is available for all other activities like food, it can be shelter, it can be traveling, etc., etc. So we found what is the share available for agri-food sector globally. So for this, we used an approach called grandfathering. I don't want to go into much of details. And then we assigned a share of the global agri-food sector to the New Zealand agri-food sector. And for that, we have different methods. And we used 4 different methods. First method is called grandfathering. So if New Zealand agri-food sector is creating some particular percentage of impact in a certain year, they will be given the same amount of budget in the future to emit. So this is called grandfathering approach. And there is the other approach called economic value. So if New Zealand's agri-food sector is contributing to, let's say, 50% of global economy, so New Zealand should given a 50% of carbon budget. Third one is agricultural land. So to do agriculture, you need agricultural land. So if New Zealand has this percentage of agricultural land globally, so they have to be assigned the same proportion of agricultural land for agri-food production. Finally, we use the approach called calorific contribution. The primary purpose of producing food is to feed people with better nutrition. So we assign the share of the carbon budget based on the calories produced by New Zealand agri-food sector. So likewise, using the same 4 approaches, we calculated the carbon budget for different agri-food industries and products. Then, as I said, we calculated the climate impact of those products and industries using process-based LCA. So now we have the impacts and as well as targets so that you can compare the impacts against the targets. So I show some interesting results. For example, here you can see 4 different columns and a dashed line which goes across the red color column. So the dashed line, 56.3 megaton CO2 equivalent, is the carbon emissions of New Zealand agri-food sector. And the 4 columns are the 4 different limits set by different allocation principles. So now you can see from an economic perspective, New Zealand gets a larger carbon budget compared to other 3 approaches. So if you want to show New Zealand is a sustainable country in terms of agri-food sector, you can use the economic approach, whereas for other approaches, New Zealand is not doing really good. So this is the case for agriculture products which we export to niche markets. For example, New Zealand wine or New Zealand kiwi fruit, they have a really good market in the international market. So given that, they get a good price for their products. For example, if you take Sri Lanka as an example, Sri Lankan products might not get a good price at the international market compared to New Zealand. In that case, they might be given a lesser priority in terms of carbon budget. So likewise, we did the same analysis for different agriculture products in New Zealand. One is the kiwi fruit, apple, and then also we did for wine. So as I said, again, in terms of economic aspect, you can see New Zealand is getting more benefit in terms of carbon budget. The second case study is about setting a carbon budget for a building. So if you are going to construct a house for you or for your family, we have kind of developed a policy in New Zealand. So this is the maximum amount of greenhouse gas emission you can emit throughout your lifetime of that particular building. So you can't just construct what you want by emitting a large amount of emissions. So we have brought this into the policy and have now we are in the process of legalizing that so that you can't emit a large amount of greenhouse gas emissions to just for the sake of getting a luxury life. So what we did, we evaluated the climate impact of existing building types in New Zealand, the residential dwellings. So one of them is a detached house, which is the common type in New Zealand. This is like the normal house which we have in Sri Lanka, which is built upon a normal land. And then medium density housing is more like, let's say in small plot of land, there will be like 8-10 houses. Now we can see such kind of projects coming up in Colombo and other suburbs. And the last one is apartments, which we know is there are high-rise buildings are now all across Colombo. So what we did, we picked many of those houses, different types of houses, and did a process-based LCA to evaluate the climate impacts of those buildings. And then we calculated the climate targets for two different climate targets, 1.5 degrees Celsius as well as 2 degrees Celsius. And as I already explained, we calculated the carbon budget, which is related to these two climate targets. And then we did a kind of an analysis to come up with a carbon budget to say, okay, this is, if you are building a detached house, this is the maximum amount of greenhouse gas emission you can emit throughout your 90 years lifetime of the building. So I show some interesting results which we found in New Zealand and which were actually shocking for us. So if you take the three different types of buildings, the first one, DH, means detached house, and the second one, the second set is MDH, and the third set is apartment. So you can see the greenhouse gas emissions of a detached house compared to the 2 degrees Celsius climate target. It's around 5 times higher. So what we are supposed to emit is around 300 tons, let's say 280 to 90 tons CO2 equivalent throughout 90 years lifetime in a detached house. But the carbon budget which we have at the moment is 50 tons CO2 equivalent. So this shows that the current way of construction is not sustainable, and how engineers and architects or designers gonna interfere in order to come up with kind of new strategies to reduce the greenhouse gas emissions. So here, as production engineers, we have a key role to play in order to designing sustainable materials and sustainable construction practices. So this is not a construction practices when it comes, it's kind of, sometimes it may go beyond production engineering capabilities, but it also has some key roles which production engineers can play in. Likewise, you can see our results for medium density housing and the apartment as well. So compared to a detached house, the environmental impacts of a medium density housing and apartment are quite low, but they are not that quite low. Still they have to reduce their emissions significantly. So the third case, which was about how each person or each individual is emitting in terms of greenhouse gas emissions. What is his personal share? For example, let's say you live in a country, like let's say you live in Sri Lanka, and you want to know whether I am emitting more than the carbon budget which I am allocated to. It's something beyond the product or sector to a personal level. So what we did another study on focusing on New Zealand's economy. Again, the same methodology, but we used a different approach called multi-regional input-output based LCA. I'm not sure whether you have heard about this term, and I don't expect you to get to know about this kind of analysis at a bachelor's level, but I'm pretty sure at a master's level or PhD level, you would have surely learned or at least heard about these kind of things. So what we did, we evaluate the climate impacts of New Zealand, both from production perspective and consumption perspective. So what does this production perspective means? So if you produce a product and export to another country, you are responsible for that particular emission. That is called production-based emission. So let's say in Sri Lanka, you may be doing a lot of production, which may be consumed within Sri Lanka, and some may be exported to other countries. But all the emissions which occur within the geographical boundaries of Sri Lanka are assigned to Sri Lanka. But the other perspective, consumption perspective, is about the emissions which are associated with your own consumption. For example, if you take same example, New Zealand might be using X% or 10% of the food produced in Sri Lanka, whereas it might import dairy products from New Zealand for their own consumption. So now we're going to evaluate the climate impacts associated with New Zealand, the food produced in New Zealand and consumed in Sri Lanka, and food produced in Sri Lanka and consumed in Sri Lanka. So that is the consumption perspective. So it's again, how you're going to inform your climate impacts, or how you're going to inform your environmental impacts in terms of two different perspectives of the supply chain. I'm pretty sure you have heard about this supply chain, different perspectives, how you're going to evaluate from a production perspective or from the end value chain, the consumer perspective. So, and then we also set the 2 degrees Celsius target to see how New Zealanders are operating in terms of the 2 degrees Celsius climate target, but at an individual level. So I'll show some scary images. So this is a kind of an analysis outcome. So we have on the left, you can see the different sectors of New Zealand and how the climate impacts look like. So of course, you know, New Zealand is one of the largest agriculture countries. So our agriculture emissions are quite high. And on the left side, you can see those countries to where we export our products. So for example, large amount of agriculture goes to rest of the world and Australia, and USA, China. And on the right side, you can see New Zealand's consumption and from which countries we import the most. So this will give a kind of a perspective how New Zealand's production versus consumption emissions vary. So if you take in this case, New Zealand's production-based emissions is around 81,000 kilotons CO2 equivalent, whereas New Zealand's consumption is around 61,000 kilotons CO2 equivalent. So this shows now New Zealand as a country produce a lot of food products, including food, and export to the consumption of other countries. So it's like a more or less, we are feeding the rest of the world. And when you take the results and compare in terms of the carbon budget, which is available per person, from a production perspective, you can see New Zealand is doing really bad. So we are exceeding our carbon budget by a factor of at least 2 and a factor of 10 for the different approach. And from a consumption-based perspective, you can also see the similar outcomes. So the two lines which you see are the carbon budgets assigned using different approaches, and the columns show the carbon emissions, which are quite high when you compare to a normal citizen of a let's say if you compare to citizen of Sri Lanka, these emissions are significantly high because of their different lifestyle in New Zealand. So what we learn from these kind of case studies and what are the challenges which require future research or future analysis are just to summarize. So as I talked over these slides, you may have seen each of these case study involved with a large amount of value choices and modeling choices. So when you have so many assumptions, then of course you have to do a large amount of uncertainty analysis. And this is what we study at production engineering, as when you design production planning, or when you design product layout, you know how to tackle different types of assumptions, those skills which we bring into different policy making. Even still, I use those techniques at an international context when I work for the government. And as I said, environmental impacts, they are not always global. There are local environmental impacts. So sometimes we need local solutions. So this is again the same example of the speed limit which I was talking. 70 kilometers per hour is risky in Sri Lanka, but 70 kilometers per hour in New Zealand is pretty safe to drive on roads. So again, environmental impacts need local solutions to address those problems. And when you talk about local solutions, so you need local boundaries as well. So for example, if you take the Vilpattu deforestation, which happened in Sri Lanka. So imagine if there are 1,000 trees in one plot and you cut one tree, that is different. And if you go to another plot where there is only one tree and you still cut that one tree, the impact is different. So you can't say, I just cut one tree, but we want to give the kind of picture where, or the context where you cut that one tree. This is same with the other environmental impact categories. How you tackle those environmental impacts on the basis of the particular context is quite important. And then this is a other new area which I don't know how far you have heard about this science-based targets. You can just Google and see. It's quite a popular research area these days. How these companies are setting science-based targets or climate targets and other environmental targets for their companies so that they can reduce the environmental impact so as the environmental impacts of the entire Earth. At the moment, we are working with many other universities around the world around 30, 40 universities across the world, and we are doing more case studies to improve this research methodology so that we will have a method with less uncertainty and more credible outcomes, so that these methods can be implemented in other countries, and especially in developing countries. So far in the presentation, I was talking about climate change only because I don't want to talk all the environmental impact categories and put too much information on your head. But the thing is, we have to focus on other environmental impact categories. Not only climate change will save us, we have to focus on other environmental impacts as well. And that is very important when you are a production engineer. When you design a system, you can't just focus on one particular variable and one particular constraint. You should know how you're going to tackle a multi-constraint problem. This is where you do this multi-criteria decision making, which will be handy at that time. And it's not only about environmental sustainability, you have to focus on social sustainability, and more importantly, it's all about money at the end of the day you make. So all the solutions, you should know how to sell the solutions. Otherwise, your solutions will be ending up in a bin only. So that's it. So I'm happy to involve in the question session. So you can now shoot me with your questions. I'll try to answer.
I think if participants have any questions, they can raise their hand so I can enable them to talk. Kamal, I think you can talk now. Kamal, you can ask your question. Or Ravindu.
Hello.
Yes.
My question is, what do you mean by the indicators in the first slides?
Okay, indicator is just like how you're going to evaluate the environmental impact. So for example, if you take the same case of the car driving, so your indicator will be your dashboard, which shows what your environmental impact is. Did you get it?
Okay, I got it.
Yeah.
Yeah, I get it. Thanks.
Yeah. No worries.
The participants, Jana, that is all I can see. You can talk. Jana, unmuted your mic, you can talk.
Oh, probably now. Kamal can ask now.
Or Rajiv.
Yes, hello, can you all hear me?
Yeah.
Yeah, so my question is, so in the case where a company, like if a company has a production facility placed in another country, and so they would have to comply to the standards and benchmarks demanded by the parent company. So
yeah.
these standards will be, like imposed depending on the environment and the economy and factors considered in that in the relating to the country of the parent company. So there is this. So when it comes to implementing this and achieving these standards, the companies, the production facilities where the countries at which the production facilities are located, how would they relate to these standards and benchmarks, because they would have a different economy and they would have different standards that they need to comply to in
Yeah.
terms of the country. So how would you solve that disparity?
Yeah, so in this case, as I said, the supply chain has two different perspectives. When one is the production perspective and the other one is the consumption perspective. So the context which you were talking is how we see the problem, or how we kind of meet those guidelines from a production perspective. But in this case, the solution should be from the consumption perspective. Now, let's say, for example, a brand like Nike says the consumer suggests that, okay, if you don't adhere to the social guidelines in, let's say, Bangladesh or Sri Lanka, we won't be buying your products. So then in that case, even though not adhering to the social context in Sri Lanka or Bangladesh is okay in those countries, now the parent company has no other option. So they have to implement achieve those guidelines even at a higher cost in those countries. So this is where we have to kind of come to a balance between the production and consumption perspective. So which we call as shared perspective, where we have the both people's interference.
Okay.
Yeah.
Thank you.
No worries.
So is there any other questions? There's one already posted by Kamal. I think his mic is not working, so I'll just present it to Chanjief. Is it possible to find a global carbon budget for specific product, for example, tea industry?
So you can use the approach which we have developed, and you can feed the data so that you can come to an answer like, if you are producing 1 kilogram of tea, this should be the carbon budget. Yes, it is possible.
Mm-hmm.
Yeah.
Now, you mentioned during your presentation that you are working with many other countries, especially some developing countries. What are the countries? Are they predominantly doing the agriculture, or any other industries also being tested, or what kind of comparisons you do?
So we are working with many developed countries so that the approaches will be available for developing countries.
Mm-hmm.
So we are working with, for example, as you may have seen the first slide, we are working with the International Energy Agency. So I'm kind of advising them to develop that building approach to be implemented across the world.
Mm-hmm.
In that project, ETH Zurich is also a partner of the project. So that is one thing we work in terms of building. And in terms of the overall approach, we have kind of a headquarters at Technical University of Denmark. I worked there previously, so we started this project when I was there, where around 20 plus universities are working together on improving this approach. The group is called LCA Absolute.
Okay.
Yeah, how LCA will be used for absolute sustainability. That's the short abbreviation of LCA Absolute.
And then how about the data? You know, country-specific data. You are dependent on country-specific data even to do this kind of analysis. So how you handle that situation? Because there are complexities when it comes to the data or life cycle inventories of the particular region or country. So are you dependent on some of the databases currently available, or?
Yeah, so for the input-output analysis, our database is with the University of Sydney. So they are kind of managing all our databases, which need a lot of powerful supercomputers. So they have got all the supercomputers. So for example, let's say if you want to run the analysis for Sri Lanka, for example, you have to give the scenario. So how this sector will look like in 2050 if the economy changes like this. So if we give the scenarios and the assumptions, then they will run those models in the database and they will send the results to us. Then we will use it in the paper. For a process-based LCA, we have to rely on published studies only. But for agriculture products, we use the database which is currently held by Agroscope in Switzerland. Yeah.
Thank you.
Yeah.
And one more question already posted to Q&A, that is on how we can do an uncertainty assessment.
Uncertainty assessment, yeah. Good, good question. So what we did, for example, the slide which I had showed about different allocation principles. So if there are, let's say, 5 different options, what we do is we use all those 5 different approaches and get the answer, and we use the answer with the minimum uncertainty. For example, if you say, in the case of the same speed limit, there are 5 limits, say 70, 80, 90, 100, and 110. So those are the limits. So if you take the 110, then someone will get the free ticket. So what we think 70 should be the target. So there can be, no one can escape. So when more science is available, then we will improve the limit. So that is how we, at the moment, negate the uncertainty. So we have worked on different uncertainty, even for calculating the carbon budgets using different models and how these different models influence the results. So you have to, what we do is we get the best options and then evaluate to see the uncertainties.
Okay, thank you, Chanchief. Any more questions to ask from Dr. Chanchief? Rajiv, do you have any more questions? I still can see your hand is raised.
Let me ask one question. So I've heard that the milk powder production is a very carbon inefficient way of producing milk.
Yep.
So question 1 is, does it show up in your assessment? And question number 2 is, would that lead to an alternate form of milk in the future?
Okay, so regarding the first question, so the dairy sector is generally categorized into 2 different systems. One is the pasture-based, so where cows are just let in the free lands and cows just roam everywhere and just eat the grass, and we get the milk. That's what mainly done in New Zealand. But the other one is the household or the shed one. So the cows are put into a shed, and then they are kind of milked on a daily basis, for example, in the Netherlands. So the 2 different contexts. So the emissions in terms of pasture-based systems is compared to shed ones are low, but it doesn't mean that it's quite low. It is significant. It's very, very significant. And the free ride is for the beef sector. So in New Zealand, for example, if you take milk, we think all the cows are there for the main purpose is for milking. So the environmental impact which is assigned to beef is low. So that is a free ride which get from that sector. And so regarding your second question, in alternatives, yes, of course, plant-based alternatives is the solution. So we have done different LCAs for pea-based products. At the moment in New Zealand, we are focusing on shifting our economy towards a more plant-based sector. So we want to reduce the amount of dairy sector production and focus on alternative plant-based protein sources.
So,
but the thing is, those products come at a high price compared to the ordinary products.
So what do you mean? What do you mean by plant-based products?
So, for example, if you take pea, you can use pea as a kind of alternative source of protein instead of having beef all the time. Mm-hmm. And there are kind of this protein can be sucked from the peas, which can be then used in food processing.
Mm-hmm. What will be the replacement for the dairy industry, milk especially?
So that's what we're going to do. We are, for example, in one region at the moment, we are working, it's called Canterbury, Christchurch, we may have seen the cricket matches. Mm-hmm. So in that region, what we are doing is we are reducing the amount of dairy production by displacing those land and start growing green peas in those lands.
Mm-hmm. So what will be the...
And also we are also...
Yeah, what will be the social sustainability of these changes? Will society accept these changes, or what kind of work you are doing with respect to that, or you are only focusing on environmental sustainability?
So initially we did the project just finished last month. So we initially did the carbon footprint assessment in terms of this displacement, how much environmental impact can be reduced. because in New Zealand, it's not only about carbon footprint, it's about eutrophication as well. So we should reduce dairy production, otherwise our water resources will be polluted so that we don't have enough water to drink. That's the main issue. So when it comes to the social aspects, as far as we had conversations with local farmers, they are happy as far as they get the income as they have been getting so far. But the issue is, let's say if you take a dairy farm, which will be operated over a year, but if you take peas, you can only grow peas for 6 months. So what are you going to do with the land for the next 6 months? That's the main issue for them. So at the moment, we are working with different crop rotation effects so that we can see how this the rest of the 6 months can be used in a potential way so that they can earn some more money. But at the end of the day, as I already said, if you want to implement a solution, sustainability solution, you have to talk in terms of rupees or dollars and pennies. Otherwise, they won't accept it.
Yeah, that's right.
Yeah.
Okay, so there's another question posted. Hope you are not tired, right? So these
No, fine.
this is again asked by Mr. Kamal. So how to create environmental benchmark for a product, and what are the factors that we should consider?
So what kind of product is referring to?
How to create environmental benchmark for product, and what are the factors that should consider? I think it's agriculture, because he did some LCA based on agriculture sector before.
Okay, so if you want to, for example, if you want to set a boundary for climate change, then it's a kind called a top-down approach. We take the global carbon budget and downscale to a product level. But when it comes to, let's say, freshwater use, you can't use a global boundary. You have to use a local boundary. So for example, if you are like, let's say, taking some water from a nearby reservoir or nearby river, you have to make sure that this is the maximum amount of water you can extract during one particular period. So you can't extract 1,000 liter water from Nuwara is not same as the 1,000 liter water from Anuradhapura or Jaffna, because the environmental conditions is totally different. So that's what I was telling. If you want to set benchmarks for the environment, different products, you have to see what context those products come from. But if he wants, I can send some papers which he wants to, he can read.
Okay, that's fine. So Kamal, you can contact directly Chanjief and get those done. And there's another question that's on what are the eco-design possibilities and how we are going to achieve the eco-design through these sustainable policies, as you mentioned.
So eco-design concepts we have been using in the building sector mostly, because we can't do much in the agriculture sector. But when it comes to building, yes, because if you take, for example, New Zealand buildings, most of those buildings are wood-based structures. We don't use much concrete in our houses. One main reason is the earthquake problem in New Zealand. So that's the reason we use wood, but wood has the capacity to capture carbon. So even though the houses show the results that they are emitting more than the budget, those emissions are significantly lower compared to the houses which we build in Sri Lanka, or which the houses that exist in the European countries, for example, the UK, significantly lower New Zealand houses building emissions. So we are using a lot of eco-design concepts here. For example, another example is the insulation. For insulation, they use, I think, some husk. I'm not sure it's not coconut husk, but some sort of husk as an insulation material. So as according to your question, yes, they do a lot of eco-design implementation. So that's what I was saying. There is a huge potential for production engineers. I still believe that being a production engineer was very handy to become a scientist. Easy. You can implement a lot of stuff easily.
So you said that you have taken up a new assignment on policy related in one of the New Zealand ministries, right? So how do you find this knowledge to be practiced in policy advocacy levels, etc.?
So the how ministry is working, most of the developed countries, I think there will be a policy advisory team where I'm a senior policy advisor. So we work together in what solutions should be implemented during the next budget. For example, the project which I was talking about, the reducing the dairy production and diversifying agriculture sector in New Zealand is kind of a future proof. So what if we get some disease in the dairy sector, the entire economy will collapse, because our economy is now relying on the dairy sector mainly. So we want to diversify our business so that if something goes wrong with the dairy sector, we can still survive with other agriculture sectors. So I see here we have a huge authority compared to, I always say, our minister, you can't even speak a word without our permission. So we have the power to make impactful decisions at the ministry.
Mm-hmm.
Yeah.
So that means they are listening to policy advisors, right? Ministers.
Of course, they have to listen. They have no other options.
Mm-hmm.
Yeah. If you say no means it is no only. Yeah.
So Rajiv has another question. So Rajiv, you can ask. Sorry, I detected wrongly. So is there any other questions to be asked from Dr. Chanjief? Okay, Jana? Yeah. Yes, you can
hear
ask.
me?
Yeah, yeah.
What are the environmental impact accessed on these case studies?
Sorry, can you repeat?
What are the environmental impacts accessed in these case studies?
So we primarily focus on climate change impact because that is a major issue. But our group means that our colleagues, they focus on other environmental issues like land use change, freshwater use, and as well as phosphorus and nitrogen effects. So we are focusing on a large number of environmental impacts. But the case studies which I showed today are mostly climate change, just to keep in the context simple. Yeah, so you can do it for all other environmental impact categories.
Okay, thank you.
Yeah.
Yes, Rajiv?
Yes, sir.
Rajiv, you can ask the question.
Yeah. My question is actually a question, career related question. So
Yeah.
so I'm as an undergraduate following the production engineering stream. What opportunities do we have in Sri Lanka when it comes to sustainability? What opportunities in regard to further learning, specializing in that field, and also what opportunities we have when it comes to a career.
To be honest, I'm not a good person to answer this question from a Sri Lankan perspective because I have a little experience working in Sri Lanka. I'm sorry.
That's fine.
So
I have
Rajiv, yeah, I can comment on it. There are a couple of options as far as job profile, job opportunities are concerned. Before COVID-19, there were many industries really wanted to go towards sustainability, especially on sustainable manufacturing practices. So most of the leading manufacturers like Unilever, Fonterra, etc., they had separate, designated official to look into these aspects, especially on sustainable manufacturing practices, etc. I think their policies are not going to be changed even post-COVID situation. So there will be plenty of industrial opportunities. And on top of that, there are opportunities even in postgraduate level as well as research. So there are quite a few opportunities available in different universities. But in foreign countries especially, there are many opportunities to do some postgraduate studies on this area, because that is one of the emerging areas, and it's really very much important for the whole world. So therefore, there are a lot of research going on. Even you can now, if you have the interest, I think you can even switch to other industries. Like Chanjief originally start with bioproduction engineering, manufacturing side, especially. He did a lot of research on mathematics side, and then later switched to LCA and combine LCA with eco designs, etc. And now he's in the policy level, basically. It's so the opening ups are, there are plenty of opportunities in this area, but only thing is your keenness, right?
Yes, thank you. Thanks a lot.
And just adding to the point which Sir made, I have another couple of slides on these opportunities, especially arising from our ministry. Can you see my slide still?
Yeah, sure.
Yeah, so we from our for New Zealand there are plenty of scholarships, but I would like to kind of flag the scholarships which we give in our ministry. So there are two different types of scholarship which I kind of just went and checked, which are relevant to Sri Lankan guys. So this there's one called Grad scholarship. This is for, you can take a research visit up to 6 months and is well paid, 20,000 US dollars around, that is 2 million Sri Lankan rupee for the 6 months time. Last year we funded 73 people, and this year we are planning to hit a mark of 100 in terms of funding to these people. The unfortunate thing is not many people in Sri Lanka know such a program exists. So that's what I thought, okay, let me include in my slide. So, and I have included the link for the program, so you guys can have a look when you have some free time. This is for people who have enrolled in PhD programs in developing countries, including Sri Lanka. So there's another PhD program. This is called NZ-Grads. So NZ-Grads is a PhD program for science students. So you should be from a STEM background. So that means our production engineering students can enroll in the program. So a scholarship for 36 months, which will cover everything: tuition fees, stipend, insurance, including your flight tickets. Only thing, you have to be from a developing country, and you should contact one of the professors or one of the lecturers in any universities in New Zealand, and they should be happy to recruit you as a PhD student. So even though we say that greenhouse gas emission from agriculture system, it can be anything. Like you can come up with some robotic solution to evaluate something. So we have one guy who's working on remote sensing, for example, I'm saying. So there are robotic, one guy is developing some robotic pad to measure some pain on cows, etc., etc. So there are plenty of opportunities, and I have put that link as well. So these are the ones which come directly from our ministry, but there are plenty of opportunities in New Zealand. And the good thing is Sri Lankans have created a good, have made a good impression about how they have come and impressed different areas of Sri Lanka, New Zealand. So you have plenty of opportunities here. And yeah, that's it. So if you have any questions, feel free to contact me directly. I have put my email address on the presentation slide. Happy to always support you guys. And we just started a project. Before this, I had a meeting with the Ministry of Agriculture in Sri Lanka. We are working on a big project to invest a large amount of money to uplift Sri Lanka economy at the moment, a post-COVID economy. So I'm always there to help you guys, and you can just drop me an email if you need anything. Yeah, that's it. Any question? Any more questions?
Do you have anything to post? I'll check Q&A also if there are new ones. Okay, so that's it from Q&A. I hope that Dr. Chanjief also a bit tired now, because it's what's the time there now? It's almost 10 or 10 or
it's 12 p.m. It's 11:50 p.m.
Sorry for keep you waiting for 12.
No, that's fine. That's fine.
A reasonable time from our end. That's why I wanted to have it at least at 4. But usually we are thinking of having it 5 or 6 o'clock here. But anyway, yeah. So I'll take this opportunity to thank Dr. Chanjief for agreeing with me to have this inaugural talk in DMIE webinar. So we were very much happy to pick him as the first speaker because he's very recent graduate, and we are very proud of him because of his performance at the undergraduate level as well as postgraduate. And he's very closely working with the most of the staff members at the department university. So we are very proud of you, and we are very much grateful for your contributions, especially to enlighten our staff and then postgraduate students, as well as some of the alumni, as well as some postgraduate students from other programs as well. So I have invited several postgraduate program students as well. So they, I think, hope got reasonable inputs from this area, because some of them are not fully aware of this sustainability side at the moment. They are started to learn, etc. So therefore, I hope that almost all the participants got something out of it, and it's very really fruitful time you spent with you. So again, I would like to thank all the participants for joining the session, as well as my co-host, Mr. Namal Bandaranaike, for assisting me, and especially to Dr. Chanjief Chandrakumar for willing for his contributions, especially to make this event a success and make this event as we planned, because we initially discussed to have it somehow in June. So you agreed and you gave me the first possible opportunity I wanted to give you. So that was really great. So I am very happy about it, and we hope that you will have a very close relationship in time to come, and in future also you will be able to talk more about the Sri Lankan project or something new, so that will be very much useful for our guys. Thank you very much, Dr. Sandeep.
Sure. And I have one kind of suggestion for undergrad students, maybe useful, I don't know. So when you do the undergrad, make sure the technical stuff which you study, don't just do the scoopy stuff and pass the exams. You get the core of those subjects, because some of the subjects when I was studying, I was not sure why I'm studying those subjects. But when I come to this kind of level, then I actually feel the importance of learning those concepts in a thorough manner. So when you learn some subjects, so make sure that you get the core of those subjects, which will be very, very useful in the future. It can be any field. It can be, you can stay in engineering or any field, but the concepts will be very, very useful. And the other thing I would like to kind of suggest to undergrads, develop a kind of a profile which will cover both academia and as well as other extracurricular activities. Don't just be a kind of a book bee, like then one day then you don't know how to interact with people. So you build a kind of a profile which will be very, very useful to develop as a leader in the future. So yeah, that's it. Maybe useful, I don't know. If you want, you can take it, otherwise just leave it. No worries.
No, that's right. Really important. I think we used to tell these things to our undergraduates, but some really accept those, some do not. But let's hope that in future, with this kind of program, they will get the maximum benefit. Especially, they will realize, especially from this kind of advisory words, I think they will get more, and then they'll try to enrich themselves during the undergraduate level as well. So thank you again very for these valuable advices to our undergraduates. So I don't want to keep you awake for long. So thank you very much, and have a pleasant good night. So thank you very much for all the participants, and have a good evening. Thank you very much. We'll hope to meet again in a new topic with new speaker next, but I'll again invite Dr. Chanjief in future also to share some of his latest research outcomes. Thank you. Good night.
Yeah, sure. Thank you so much, sir. Okay, see you guys.
Yes,